So, hello everyone. In today's session, we are going to discuss that how one can count the number of solution a linear congruence will have. As in the last session, we talked about that what is a linear congruence, how one can find its solution. But one concern raised in the last class is what that how to count that how many solution a linear congruence is having. So this session is dedicated to this concept that how one can find the number of solution a linear congruence is having. So let us start the discussion. So consider a linear congruence. The standard form of a linear congruence as already discussed is AX congruent to B mod M. Okay. We are interested to get to know that how many solution is there for this linear congruence. Is there any solution exist or not for this linear congruence? If yes, then how many they are in numbers? So let us see the concept. So just consider the GCD of the integer a with m is d. The integer a and m is having GCD. Let it be the GCD is d. Then there are three cases for this. Case number one means this concept is based on the concept of one of the important concept of divisibility, which is known as GCD, greatest common divisor. Case number one says that if if this D does not divide your B, if this D does not divide your B, the GCD of A and M does not divide the number B. This how to read this line? A vertical line crossed. D does not divide B. D does not divides B. Does not divide means not completely divides B. So if D does not divide B, then the given congruence 1, then 1 did not have any solution. Did not have any solution. That means before starting with the solution of a congruence, we are supposed to check it. It may the linear congruence do not have any solution. So if it is not having any solution, we can't find the solution. And this can be checked by using this concept. Case number two. Case number two says that if your GCD divide the number B, how to read it? We will read it as D divides B. D divides B. Then in this case, we can say first is having the linear congruence, first is having D number of solutions. Be attentive on this result. I am not saying that the equation is having D as a solution. What we are saying that the equation will have D number of solution. That means if GCD is 4 and 4 divides M, the equation will have 4 solution. There is case number 3, which is the subcase of case number 2, which is says that if the GCD is 1 and 1 divide every M, 1 divide every B, sorry M. So whatever B is there, 1 always divide that B. So in this case, if D equals to B, then first will have, unique solution. Unique solution means only one solution exists. Only one solution exists. So this is the concept. By using it, we can come to know that how many solution a linear congruence is having, whether the solution exists or not. Let us take one example, which I taken as the last example of the last class. 12x is congruent to 18 mod 42. So we are supposed to find the solution of this linear congruence. Before jumping that how many solution it is having, first try to find the number of solutions it is having. Okay, so we are interested to find the GCD of what? 12 and 42. The GCD of 12 and 42 is 6. And we can say 6 divide 18. Yes, 6 divide 18. It means this equation first will have 6 solutions. When we solve this example in the last class, I think we only find the one solution. So the given equation is having 6 solutions. That can be found by the method that we discussed. That means put the values of t in the given equation, which make x as integer. We needed 6 different t's, which make 6 different integers for x. And all those will be the solution of this linear congruence. If I take one more congruence, uh, let us see one more example. We are having 4x is congruent to 3, let it be mod 6. Find the solution of this congruence. Over here, the GCD of 4 and 6. Over here, the GCD of 4 and 6 is 2, and we can say 2 does not divide 3. Hence, the given linear congruence do not have any solution. Okay, so this is how we can comes to know that whether the given congruence is having solution or not. If yes, then how many they are in numbers. I hope you understand the concept. That's all for the session.